Introducing Cancept, an open-source analysis and fault injection tool developed to advance the verification and validation of controller area network architectures. Upon starting Cancept, you are greeted with the option to upload a database CAN or short DBC file. This file serves as a translation layer between raw messages sent over the CAN network and physical values of measured signals. In the Overview tab, an overview of the loaded DBC file is displayed. In this case, for example, the file features 6 uniquely defined messages. Switching to the Messages tab gives detailed information of the messages and signals contained by them. The Signals tab directly displays information for the signals. To watch traffic over the CAN network, we first need to select a CAN interface in the Settings menu. For testing, a virtual CAN device has been set up that loops back all outgoing traffic as incoming traffic. In the Monitoring tab, each signal of each message is displayed in decoded, human-readable form. For better visualization over time, a graph for each signal can be shown that shows the signal for the past minute. For example, here the engine speed in RPM is plotted over time and a simulated motor start is shown. The main use case of Cancept are the Sending and Logging tabs. In the Sending tab, you are able to directly manipulate the CAN network by sending signals to it. Sending can be done on 3 ways. You can either send CAN messages already defined in its raw form, consisting of an 11-bit message ID and a maximum of 8 bytes of data. The second way is to define the to-be-sent messages as signals described by the loaded DBC file. Here we define signal states for the indicators based on the DBC. Each signal gets its own function that is evaluated as a message is sent. For example, here the left indicator will always be set to 1. For the right indicator, we define a variable t that measures the time since the sending started in seconds. Using the sinus function, we can now define a periodic signal that switches between 0 and 1 since it is rounded and then clamped between 0 and 1. We can now turn on repeated sending that sends the defined message on an interval, here 100 milliseconds. Switching to the Monitoring tab, we see both signals successfully being encoded, transmitted, and then decoded again for the visualization. Cancept also allows the use of more complex functions for signals. Here we define a sinus wave for the parking sensor that is scaled on the y-axis. Additionally, we can add manipulations to the message. For example, here we define a DBC-based manipulation. The manipulation is triggered by the distance of the parking sensor being over 150. Then we add a noise of amplitude 20 to the signal before sending it. This could simulate a sensor having a defect or being unreliable on large distances. Switching back to the Monitoring tab, we can observe the manipulated signal. Next, we want to log our observed CAN traffic. This can be useful for external analysis or replaying of the traffic. For that, we switch to the Logging tab, where logging sessions can be started. Here we start a raw logging session that logs all incoming traffic in its raw CAN form. After stopping the session, a detailed view with all recorded signals and session infos can be viewed. Now we can export the session by clicking the Export button. Cancept can export log sessions either in CSV or in industry standard MDF4 for a broad and easy use in already existing external testing pipelines. Cancept also allows to replay logged sessions or external files in the MDF4 standard or the Cancept output format of CSV. For that, we switch back to the Sending tab and there the Replay Logs subtab. Here we can upload our exported logging session and start replaying it on the CAN network by clicking the Start Replay button. Now the recorded traffic is being replayed. Here there is also the possibility to generate manipulations on the outgoing signal. Here we define a manipulation that is triggered randomly at a probability of 50%. The manipulation then delays the message by 30 milliseconds, simulating a delay on the CAN network. Also, the replay is done at double speed. Switching on the Monitoring tab, we can see the sinus wave now also being misformed on the bottom of the wave caused by that 30 milliseconds delay. This concludes the showcase of Cancept.